Everybody, it's Tyler here with Behind the Bumpers, here with team number 3197, the HexHounds, out of Cedarburg, Wisconsin. And we're going to be showing off actually their 2021 robot that they've created here, an incredible machine that they have. They worked on it 2020, so we're going to be talking about a lot of the differences as they go through too. And I'm here with Cooper, Zach, Jared, Yuri, and Leah. And we're going to be talking about the new intake that they've developed on the spot. New hopper, a really awesome shooter, and it might be the loudest shooter I've heard in FRC, by the way. They just did a sword drive for the first time, and then they have an incredible new shop that we're going to be running through here, all on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FRC to join their team as interns or for a great career. Come join a company that will actively support you being in FRC at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumpers segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Cooper, take me through this robot. We're going to go through the power cell journey that is on here, starting with this intake, and tell me some of the differences between your 2020 robot and this robot as well too.
So on this intake, we really tried to simplify it. Last year it said 3 rollers. This one only has 2, and it's just these 2 plates. It's got the 2 rollers, sucks up the power cell, and then the ramp is just kind of these 2 churros, very simple, and then 2 more churros up here to support it. It's driven by a Neo 550 down here that goes through some of these orange belts to power both rollers.
So let's take a look at your 2020 robot real quick here in the intake that it has. And tell me about, like, why did you choose to go with the differences versus it's like, when you looked at this robot, you're like, hey, we can do this better. What was some of the thought process behind this?
Yeah, this one, well, the balls would come up through here and they could just come right out of here. And so we changed the geometry a bit to make sure the balls stay in and can't just fly right out like in this one. And, well, we went down from 3 rollers to 2 because in the new geometry I thought we only needed 2. We found that in prototyping. It worked out pretty well. And other than that, I really just stuck with the same things, the same orange belts, same motor. Didn't change too much. Sure,
that makes a lot of sense. So we're going to be going over to Zach next. And actually, I want to stick on this 2020 robot here for just a moment. So Zach, why don't you come over here and tell us a little bit about the hopper here, what worked, what didn't work, and then show us on your 2021 the improvements that you made as well.
Okay, so the hopper lifter on this robot, it's a 2 conveyor belt system, so the power cell will come in through the intake into here, and then it'll be slowly dragged through this hopper into the attached lifter that we had. And the main difference between this and the 2020 robot and the 2021 robot is the way it's fed. This is just a standard flat plane, which didn't really work out too well with like our entire system. So in 2021, we switched to a angled sort of gravity feed with an agitator in it because we wanted to design it as passive as possible. So the balls will get into the hopper very well through the intake. Sean, would you like to run the intake? So you go up into the intake as well as they're gonna rest in here. The agitator will come on. It's I believe this is a BaneBots, actually.
Oh, okay, wow.
It's a BaneBots surgical tubing holder on a Neo 550. And we found that it actually worked really well spinning backwards as opposed to spinning forwards. And it just gets all the balls serialized and ready for the shooter and lifter.
Now, you're telling me before we started this interview, initially you were looking at doing a passive design on this as well. So I'm going to infer that the power cells had some jamming issues, and that's why you went this route?
Yeah, we tried very, very hard to get it to work passively, but we ended up having to put an active element within our hopper because there was just too much reliance on random chance, and there would be the one situation out of a million where it would always get jammed. So we decided to go with an active agitator inside to the hopper.
No, I love it, and we're going to be talking more about the packaging of this robot. This is a very clean robot, and I really love that so much as well. So next up, we're going to be going into the shooter, and that's going to be Jared, who's going to be talking a bit more about this. And I mentioned before we started, this really is probably one of the loudest shooters I heard in first. And of course, our microphones are going to do that justice when it picks it up. But I really love this flywheel you have. It's just massive on here, and a couple of huge, massive Coulson wheels. And I know you did a little more on the adjustability of this. I'd love to show that off too.
Yeah, for sure. I'll start you with the flywheel section. This is a upgrade from last year. We have a 6-inch flywheel here weighing roughly 2.7 pounds, which spins twice as fast as the shooting motor, so it can maintain that inertia just that little bit better. This year, we had a few extra motor slots laying around, so you can see that we have a total of 3 Falcon 500s, so that's new. If we move over here to the hood, we actuate it on this side. We attached a belt here to this plate, which has a sprocket, and that's just to control the angle for the shooting.
Do you know how much of a angle you get on something like that? How much adjustability is there on that?
Roughly 45 degrees.
Okay. And when you're looking at the shooter, and we're going to show it shooting a couple power cells here in just a minute as well too, but when you look at what you had on your 2020 robot, that looks like a full turret versus a fixed shooter on that other than the hood. Why did you decide to go from the turret to a fixed perspective?
Mainly out of the lack of necessity. Last year, we did not have the swerve drive, so we wanted that extra adjustability for when we drive up to the shooting area. This year, it's very easy to turn the robot with the new drivetrain.
That makes a lot of sense. Can we let's grab a couple power cells and run it through, and I actually want to see the shooter operational and functioning and see how that works too. Like I mentioned, it's going to be hard to pick up on our microphones here of how loud this actually is. So it's awesome to see on this robot. I guess a couple other things I want to talk about is you have, is that 3 Falcons that are actually running this shooter?
Yes, 3 Falcons.
So have you done any measurements or anything like that of like really how much like torque you're getting out of this or anything like that?
We did run a few calculations. I can't remember exactly how much torque we have. We looked more at the spin-up times, like
Sure.
recovery time of the shooting wheel.
And what did that look like?
That was less than, it was about a millisecond.
Sure. Awesome. Love to hear that. And we're going to keep moving on here to your drive. And one of the things I really love to highlight this year with the 2021 at-home challenges, and Cooper's going to be talking about that, I believe, is a lot of teams have been testing out doing sword drive. And this is the first time that your team has been doing this this year as well, too. So I'd love to hear more about what's worked for you, maybe some of your challenges that you've had with that as well, too. And then maybe talk a little bit about your chassis. It's a very clean chassis. It looks like a lot of it has almost been milled out of the same piece, actually.
Yeah, so we just bought one big sheet of aluminum, and these all got cut out on our new CNC router. Previously, we sent these off to a water jet place, but these were all done in-house. So it's just, the chassis was honestly very easy this year because we just bolt down the swerve modules every other year. Like the last 3 years we've done tank drive.
Sure.
That was a lot more complicated, but this, mechanically, we just bolt this on and make like a frame to hold it.
It's funny to hear the way that you're like, it was easier to do the swerve than what it was to do like a West Coaster tank, that sort of thing. So
we really integrated the intake into the chassis. This is just part of the frame. I really think of the chassis and intake as just one piece.
is this something you did all in-house as well, too?
Yeah, this is all in-house.
All right, and we're going to be actually looking at their new facility they have here in just a little bit, too. So excited to see what your capabilities are from that perspective, too. So looking at your drive, what you had, so talk to me about doing a sword drive for the first time. Obviously, very advantageous with the at-home challenges, right? And be able to do some of the auto navs and the other driving challenges well. But any difficulties from actually, trying to do a swerve from the first time? Or maybe that might be a better question for Yuri in programming as well.
Yeah, well, we chose a swerve drive, of course, because of the new challenges and, doing like the obstacle courses. We wanted it maneuverable, of course. And we have had an issue with the treads wearing down. This blue nitrile
Oh,
treads
sure,
we
yeah.
got, they have been wearing down very fast.
You're not the only team to tell me that, by the way.
Yeah.
So yeah, definitely have heard that before. So, all right, well, love the overall, like I said, a very clean robot on there. And I want to wrap up with the robot itself with Yuri and talking about some of the sensors on the robot, and maybe as a follow-up question to you, talking a little about programming for a sword drive on the first time as well.
All right, so pretty much besides the actual cameras for vision tracking, the only sensor that we have is this beam brake for the intake. It'll basically stop balls from getting past that lifter motor.
Sure.
And into the shooter before we're actually spooled up. And then aside from that, we have a intake camera and a limelight. The limelight's for judging distance and for auto-aligning with the power port, while this USB camera is for actually tracking the balls during autonomous.
Makes a lot of sense. And talking about on the drive, programming a sword drive for the first time, what was that like versus obviously, I think with the tank drive, maybe a little more simple on that end,
Yeah,
a bit more that you have to think about with the sword drive, both in autonomous and for teleop as well too. So talk to me about that.
Yeah, for sure. So originally we had some issues with getting the swerve drive actually running because we were trying to kind of mimic some other teams in their implementation of how they actually did it. But we ended up settling on using the WPI Lib actual libraries for swerve drive. And that's been working actually pretty good for us since then. And for auto, which is still a work in progress, we're using Pathweaver and trajectory following to actually run the courses.
Yeah.
Yeah.
Is that the first time you used that before?
We tried a little last year, but it was a little bit of a failure. But yeah.
So new experience, I think, and really the at-home challenges in this case kind of is your catalyst to want to do that more, right? And that's kind of the cool part about it. And here on Fun too, we've had both pros and cons with the at-home challenges versus more of a competitive game for things. And I think these are speaking to the lights of the at-home challenges, that there are a lot of great things you can learn about it. So, so next we're actually going to be taking a look, a tour of your new facility and checking out what has to go with that. So let's go ahead and take a look at their new facility here.
Alrighty, so this is the brand new 3197 build facility. We have one of our new routers. This has helped us out a lot this year, as you saw on our drive, our frame for our chassis and with our intake. You can see we had a lot of really precise router parts, which we got the opportunity to do in-house rather than sending them out to one of our sponsors. We have a new finishing room. This is able to do hydro dipping. We hydro dipped, I believe, one part, but we didn't really get the opportunity to say hydro dip all of our robot pieces, but I think going into future seasons, that's going to be something we're going to look into more. This year, we got the opportunity, we have some brand new mini Haas mills that we've played around with a little bit. Got the opportunity working on making some parts with that, and like what I mentioned earlier, making sure that, we test out kind of issues that we've had with it, making sure that going into future seasons that we can be as efficient as possible using that. Over here, there are some new Haas lathes. I know that we got the opportunity, I don't know if we had the opportunity to really kind of go in and test them with robot parts, but I know some of our metalworking classes that are in here during the school day have had the opportunity to utilize these machines. Right over there, we have our brand new field. This year we got access to a full-size practice field, and we actually got the funding through one of our team sponsors, Velo. They saw really what it was with the work that our robotics team is not only doing just for our school, but just in our community. And through a $100,000 grant, we got access to have a full field, and with that money also, it was used to grow some more tech ed programs across our school district. We just have some new kind of mini workspaces. These are for our robotics and automation courses here at Cedarburg High School. So you see here we have a lot of just VEX stuff out. This year we had the opportunity to use VEX V5 rather than using the VEX V3, which is what we typically used in the past.
Well, Leah, you have a beautiful facility. I know it's going to be put to great use here. Thanks for walking us through it. Well, 3197 HexHounds, once again, coming out of Cedarburg, Wisconsin. Really appreciate you taking the time. Not only show off your 2021 robot, which looks absolutely fantastic, but an amazing new facility you have here. Looking for great things out of this team in the future. Good luck this season and, of course, in future seasons to come. Thank you.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.